Good morning, students. Now we are going to start with the next topic, that is the fifth unit, dynamic memory allocation. Now, allocation of memory, as you know, can be done in two ways. One is static allocation or compile time memory allocation, and the other one is dynamic memory allocation. Now, we have studied in the previous classes that allocation of memory space at compile time is known as static allocation. Now, what was the problem with that allocation? You can not change the memory requirement later on, means at the time of execution. So basically, what are the consequences could be that memory could be wasted or underutilized, and if extra memory is required, it cannot be allocated. So for avoiding these kinds of situations, we shift to dynamic memory allocation. One more thing, allocation of memory at compile time is done from stack, but in case of dynamic memory allocation, it is done from heap. Now, what is dynamic memory allocation? Memory allocated at runtime. Runtime means when my program is actually under execution. Now, here basically, now what is the benefit of dynamic memory allocation? That there is no memory wasted and sufficient amount of memory is allocated. In C language, we were having malloc, calloc and realloc for allocating the memory and free for deallocating the memory. But here we have operators. In C language, we have functions, but here we have operators. Two operators we have, new and delete. Now, what is the benefit of operators? Operators work faster as compared to functions. Now, see the syntax for allocating the memory dynamically. First, we are going to have data type, then the pointer, assignment operator, new, data type. Now, come here, see the example, int star ptr is equal to new int. It is going to allocate memory to a single integer variable. If you want to allocate memory to a float variable, here float p star ptr is equal to new float. Now coming to the next, that is allocating memory for array. Now what will be the syntax? Data type, pointer name, assign new, data type, and here you are going to mention the size of the array, means how many memory allocations you want to do. Like you write int a of 10. 10 means it is going to allocate memory to 10 elements of array. Similarly, if you see here, int ptr is equal to new int 10, it is going to allocate memory to the 10 integers. New returns address of memory allocation, which will be taken by the pointer. Now, if compiler is unable to allocate memory, then null will be returned. Now, what is the journal syntax for deallocation? Now, whatever memory you have allocated through new, it needs to be deallocated as well. Now, if you want to deallocate a single memory location, simply the syntax is delete and your pointer name. And if you want to deallocate array of memory locations, your delete, subscript operator and your pointer name. Next is your memory allocation failures, means if the memory is not allocated, means memory is not sufficient at runtime. Now, how to check this situation? First, I'm going to create the pointer, data type, and your new data type, your pointer name, and new, your data type or array you can declare. Now, how p is a pointer, it could be any variable. You can have ptr, it should follow the properties of identifier. Now, if not of p, means if not enough memory allocated, I can display a message, memory allocation failure, and I can exit the program. Or the other method is if p is equal to null, means whatever memory I am trying to allocate is not sufficient, then it will be p is equal to null. Again a message will be displayed, memory allocation failure, and exit the program. In this way we can allocate, means a simple code you have to insert in every program. Int star p is equal to null, whatever will be the pointer name, Like here I have written P, the same pointer name will be here, the same pointer name I can write here. P is equal to new int, memory allocated according to you. Now if not sufficient memory, either you can write this syntax or you can write this syntax. Let's see the first program for allocating a memory to a single variable. First, int star p is equal to null, means null I have assigned to p. Simply writing this is also okay, but you know it will become a wild pointer, so I have assigned null. P is equal to new int. What this is going to do, it is going to allocate a single memory area. Now I'm going to check if memory allocated or not. This is the syntax to check. On the other one I have written here. Now memory allocated. Now what is the next step to allocate the memory, to allocate the value in that? Star p is equal to 12, means assigning 12 to p variable. Now if I display the value here, it will display, and here it will display the address. Now after that, deleting the memory or deallocation of the memory, basically how to deallocate, delete p. Now whenever I am going to deallocate the memory, and if I am going to display it after that, what this case becomes? Dangling pointer. Now here garbage value will be displayed because I have deleted the location, or I have deleted the location, but still pointer is holding the same address. So here different value will be printed but same address. So what is the solution to this? To assign null to it again. If I execute this program, see here, integer value stored 12, address, then after deallocation garbage value, but it is still pointing to the same address. This is the first basic program. Now one way of allocating memory is this. The other way of allocating memory is, whenever you are going to allocate the memory, in parentheses assign a value. Now earlier it was 12, now what is the value? 8. Remember, this is for allocating the memory to array, but if I want to assign a value to a variable, simply I am going to write in parentheses. Now if I execute, see the value 8 and address, again garbage value, and here again same address.